Dear students, in the previous video, we learnt and we discussed about the working principle of four-stroke petrol engine, diesel engine, and two-stroke petrol engine and diesel engine. So, in this video, we are going to learn about the comparison of petrol and diesel engine. Okay, how we can compare the engine and the diesel engine. So here we have three columns. In the first column we have principal, and second petrol engine, and third one is diesel engines. Okay, so we're going to compare the petrol engine and the diesel engine. So first one, the cycle of operation. The cycle of operation. So what is the thermodynamic cycle used in the engine? So petrol engine is generally use a constant volume cycle. Constant volume cycle. It's also called as Otto cycle. But the diesel engine uses a constant pressure cycle. Constant pressure cycle, and it is called diesel cycle also. This is the one difference. So next, fuel used, you know that already. Petrol engine uses petrol as a fuel, and diesel engine, okay, we use diesel as a fuel. That is the one comparison or the difference. And admission of fuel or entry of fuel into the engine cylinder. So what happens during suction stroke, okay, in case of petrol engine, the mixture of air and fuel will enter inside the engine cylinders. We know that already, we discussed. And here at the end of the compression stroke, only the diesel will be sprayed by the fuel injector in case of diesel engine. Okay, so during suction stroke only the air will be entered into the engine cylinder. In case of diesel engine, only air will enter inside the engine cylinder, and that will be compressed to high pressure and high temperature. After that, at the end of the compression stroke, after suction stroke, at the end of the compression stroke, the fuel injector in case of diesel engine will spray the diesel into the high temperature and high pressure air. So that is the another difference. And charge drawn during suction. Okay, charge means the mixture of air and fuel. Okay, so air and petrol mixture is drawn during suction stroke. Only the air is drawn into the engine cylinder in case of diesel engine. Okay, so these are all the important comparisons. Okay, like this we have few more comparisons of petrol engine and diesel engine here. Compression ratio. So in case of petrol engine, okay, it is ranging from 7 is to 1 to 12 is to 1. 7 is to 1 to 12 is to 1. But in case of diesel engine, it is very high, 16 is to 1 to 22 is to 1, because we have to compress the air to very high temperature and the pressure. So that's why the compression ratio should be very high. And type of ignition, how the fuel will be burnt inside the engine cylinder. We are going to use a spark plug in the petrol engine. That spark plug will produce the spark, and the air and fuel mixture will capture the fire and it will burn. So that is the uh, type of ignition in the petrol engine. And in case of diesel engine, the compression, okay, we have to compress the air to very high pressure and temperature, or it's also called as auto ignition. Okay, there is no device required to produce any spark to make the diesel to burn. Okay, the diesel, only the air will be compressed to high temperature and pressure. When the diesel is sprayed into the high temperature air and high temperature air, okay, the diesel will burn and auto ignition takes place. So that's why, okay, it is compression or auto ignition take place in the diesel engine. So next, uses. Okay, if you take the uses, okay, where these petrol engine and diesel engines are used in the vehicles. Okay, generally in petrol engine is used in scooter, motorcycles, okay, or the bikes and car, etc. Okay, so generally, okay, heavy vehicles, if you see, no petrol okay, vehicles, only diesel vehicles. Okay, we can, some of the cars, okay, with petrol, and some of the cars with diesel. So like this scooter and motorcycle are the bikes, and okay, cars, we generally use these petrol engines. And diesel engines are used in heavy vehicles, trucks, tractors, buses, okay, etc. When you compare the engine speed, okay, so what is the which engine is having high speed. Okay, here the petrol engine high about 7000 rpm. Okay, it can rotate at 7000 revolutions per minute. But diesel engine the speed is less, that is low from 500 to 3000 rpm. So speed of the diesel engine is less compared to petrol engine. So power output, okay, which engine will give more power, okay, to the vehicle or more, okay, by burning the fuel, how much power, okay, which engine will produce more power. Okay, that comparison, if you compare petrol and diesel engine, the petrol engine is producing less power and the diesel engine is producing more power. Okay, and thermal efficiency, okay, thermal efficiency means which engine, okay, will keep more heat inside the engine cylinder, and okay, that heat energy will be converted into mechanical energy generally in the engine cylinder. What happens, the fuel you are going to burn inside the engine cylinder, that when you burn the fuel there is some chemical reaction takes place. Due to that chemical reaction, heat will be generated by burning the fuel, so that heat will be converted into some mechanical work inside the engine cylinder. So more heat, okay, which engine, okay, if there is a heat loss, if there is a heat loss inside the engine cylinder, then the thermal efficiency is less. Okay, if the less heat loss, okay, if the heat loss is minimum, then the thermal efficiency is very high, we can get more power. So here the thermal efficiency of the petrol engine is less, okay, and thermal efficiency of the diesel engine is high. And noise and vibration, okay, when you compare, so there is a noise produced when you running the engine. So which engine produces more noise and vibration? When you compare these two, so petrol engine will not produce more noise, okay, and vibration, it is almost nil. But diesel engine, okay, will produce very high noise and, okay, vibration also will be produced when the engine is running. So these are all the important comparisons between petrol engine and the diesel engine. Next, okay, we have few more comparisons. Weight of the engine, okay, which engine is having more weight? Weight of the engine. So petrol engine, the weight is less, and the diesel engine weight is high, because we need a separate fuel injector in case of diesel engine. Okay, so we'll be having number of fuel injectors based on number of cylinders used in the engine. So what happens, the weight of the engine generally increases when there is a additional fuel injectors or fuel supply system is required. But in case of petrol engine, okay, we need a small spark plug, and we don't need a fuel injector system. So that's why the weight of the engine is less. Okay, the petrol engine weight is less compared to diesel engine. Next, initial cost, okay, so which is having more cost to manufacture or produce, which engine? So petrol engine, it is less, and but the diesel engine, it is more, because I told we need a separate fuel supply system by using fuel injectors and fuel controlling system. Here also we require, but okay, it costs less, but this one is cost more. And operating cost of the petrol engine is high, okay, but the diesel engine is less. Maintenance cost, the petrol engine is less, but diesel engine is slightly higher. Maintenance cost is higher. To maintain the engine, we have to spend more money for the diesel engine. And starting of the engine, okay, which engine is easier to start? Okay, so petrol engine we can easily start in cold conditions also, okay, but the diesel engine in cold conditions, okay, it's very difficult to start, or cold weather, it's very difficult to start the engine. So that is the another difference. And exhaust gas pollution, okay, which engine is producing more exhaust gas pollutions? Okay, carbon monoxide, carbon dioxide, okay, so which engine is producing more? So if you take petrol engine is producing more, okay, exhaust gases, and it is making our environment pollution. So and diesel engine is lesser, okay, or less. So like comparison of petrol engine and diesel engine, what you have discussed, we understood. Okay, we have another comparison of four stroke and two stroke engine. What is the difference? So here we know that already. So here in this column we have four stroke engine, and in this column we have two stroke engine, and this is the principle of working. So first one, the first difference or the comparison, that is number of strokes per cycle. We know that already. Four stroke engine require four strokes, and two stroke engine require two strokes. And uses, okay, where these 4-stroke engines and 2-stroke engines are used in the vehicle. So that is, okay, cars, trucks, tractors, okay, jeeps, buses, okay, we use 4-stroke engines. But 2-stroke engines are not used nowadays, but they were used, okay, where it was used in mopeds, okay, in mopeds, that is a small scooter and or a bike, and scooters, motorcycles or bikes, etc. We use this 2-stroke engines. Then we have power developed, okay, how much power will be developed in 4-stroke engine and 2-stroke engine in every alternate revolution of the crankshaft we already discussed, okay. So only in one revolution of the crankshaft, in case of 4-stroke engine, the crankshaft will rotate, okay, 2 revolutions, okay, to complete 4 strokes. In only one revolution of the crankshaft or the alternative revolution of the crankshaft, will get the power, or the power stroke, okay, is there only in one revolution of the crankshaft. But in case of 2-stroke engine, okay, it will take only, okay, one revolution of the crankshaft to complete the, okay, 2 strokes, so that in every revolution of the crankshaft there is a power developed in case of 2-stroke engine. So flywheel, okay, flywheel, it is a device, okay, used to store the energy produced in the engine. Okay, some rotational motion is required for the engine to move the piston up and down. For that we require a flywheel. Okay, it's a wheel, heavy wheel, which will store some energy produced by the engine in the form of a rotational motion. So that is called the flywheel used in the engine. So here the flywheel in the petrol engine is very heavy, and the flywheel used in diesel engine is flywheel used in the 2-stroke engine is heavy and 2-stroke engine is light. So that is another difference. So here we have fifth difference, that is admission of charge. Admission of charge means the entry of air and fuel mixture into the engine cylinder during suction stroke. So that is in case of 4-stroke engine, directly to the engine cylinder, directly to the engine cylinder. In case of 4-stroke engine, what we have discussed already, you know that. And by opening the inlet valve, we can directly make the air and fuel mixture to enter inside the engine cylinder. That is the charge in case of 4-stroke engine. But in case of 2-stroke engine, the air and fuel mixture first, okay, enter into the crankcase, then it is entered into the engine cylinder through a transfer port in the engine cylinder. Okay, so that is another difference. Next we have exhaust gases, okay, driven through the outlet during the exhaust stroke. Okay, in case of 4-stroke engine, there is a exhaust stroke. In that exhaust stroke, the exhaust gases will be exhausted outside by opening a exhaust valve. But in case of 2-stroke engine, driven out by scavenging operation. So next, seventh difference of the comparison, valves. Okay, opened and closed by mechanical valves. Okay, we are going to use a mechanical valve. In case of 4-stroke engine, the opening and closing of the valve takes place mechanically, and here opened and closed by piston. Okay, there is no valve in case of 2-stroke engine. Instead of valves, we have ports. Those ports opening and closing is done by a piston. By moving the piston up and down, we can open and close the ports in case of 2-stroke engine. That is the another difference. Next we have noise. Okay, what is the noise? Okay, that is, okay, in case of 4-stroke engine the noise is less, but in 2-stroke engine the noise is very high. So I given the example, the 2-stroke engines are generally used in two-wheelers or the bikes. Okay, if you take Yamaha RX 100 bike or HD bikes, okay, those bikes used 2-stroke engine, and you can understand, okay, and we can imagine how much noise they were making. So noise was very high in those bikes. Okay, but nowadays in scooters and all scooter bikes we are using 4-stroke engine, we can observe the noise. Okay, noise is very less. Okay, so ninth one, lubricating oil consumption. Okay, we are going to use a lubricating oil to lubricate the moving parts of the engine. So that is less in case of 4-stroke engine, and 2-stroke engine it is more, because high uh, temperature or enormous heat is produced in case of 2-stroke engine, so they require more lubricating oil. Fuel consumption, the 4-stroke engine is less and 2-stroke engine is more. The mileage is less in case of 2-stroke engine, but 4-stroke engine the mileage is very high, because it will consume less fuel. And mechanical efficiency is will low in case of uh, 4-stroke engine, but in 2-stroke engine it is very high. So in the next video we will discuss about the next topic, that is on refrigeration and air conditioning. Okay, so I think you understood, okay, the comparison.